Hello, good morning, good afternoon, depending on where you are. Thanks for joining. We've got our presenters are all lined up to come in here. Got Brandon Gordon coming in today, as well as Nico Guerra. A lot of good sessions coming up. Today, of course, is our advanced capacity management. This is our first, second actually session since our second session since VMware Explorer. Hopefully, a lot of folks had a good time at VMware Explorer. Got a lot of good learning in while you were there. Coming up on the 14th, next week, we're going to be doing the manage applications and services using Aria automation config. So that'll be an automation session for you. So Vincent and Scott McDermott are going to be in on that. And actually, it may just end up being Vincent. I know Scott's out running around doing all kinds of exciting things. So if we get both, that'll be fantastic. If not, Vincent's going to do the heavy lifting. But that will really focus on using Aria automation config state to create files that you can apply to several nodes simultaneously, etc., rather than doing manual configuration. Real good deep dish automation content. So that'll be good for everybody. And then up on the 21st, we have monitoring and troubleshooting Kubernetes. And that's going to be Tim George is going to be in on that one. So that'll be good. And then the 28th, automating the deployment of Kubernetes clusters. So you're getting a little bit of a Kubernetes twofer there. So there will be that one's going to be a little bit more about delivering applications and services and how to build and consume, set up your cloud infrastructure using Aria automation. So we're basically jumping automation, operations, automation, and that's probably going to be kind of the pattern moving here on out. So that said, coming up on the 15th, in about a week, we're going to try to lock down the schedule for October. So hard to believe that we're at October already. Going to be crazy to think about that. So we'll just give everybody another couple of seconds here to roll in, and then we'll get started on our presentation.
Hey, Anders, I just check, make sure you can see my screen share.
Oh, no, I cannot. How are you?
All right.
That doesn't mean it's not up. For some reason, I'm not showing myself talking or thinking. So, and I'm only showing one. I can hear you, but I'm only showing one presenter, and I'm not sure why that is.
Interesting.
Yeah. Give me
Let's
30
see.
seconds. I have a crazy thought here. Hang on 2 seconds. Anyway, how are you? Good to see you.
Doing all right.
Yeah.
How about yourself?
Doing good. Managed to survive. Explore in one piece, which was super good. I heard a lot of good things about everything going on. So yeah, I'm not seeing your share. I'm not seeing your share in the live broadcast.
All right, let me try reloading the
jiggle the handle.
Let's see.
There you are. Now I see you as a presenter. Beautiful.
Hey, it looks like it's sharing. I can tell now.
Perfect. All right, let's party.
Go for it. All right. Get it working.
Mm-hmm. Fantastic. Take it away, sir.
Okay. So this is basically the session talking about the more advanced topics from a capacity management. So I'm hoping you've already seen the first one where we went through the basically the introductory level. part of capacity management. So I'm not going to do that part. I'm just going to kind of switch in and get into the advanced topic. So I'm just going to hit the ground running. We're going to go pretty, pretty technical, pretty quick here. So hopefully, like I said, hopefully you've seen the other sessions, so you're familiar with, how the high level, the capacity stuff works. And now I'm going to get down into the weeds and explain how all the stuff is calculated and figured and all the different terms and such. So with that, I want to just go ahead and get into the session. Kind of reiterate the capacity management piece. There's a lot of aspects to it that that come into play, and I'll kind of touch on most of these going through the talk today. So showing like how much historical data is used for doing capacity management, how we handle peaks, what metrics do we use, how do we ensure that we have adequate performance, how do we come up with these right sizing recommendations, and then how we do these kind of projections. So there's a lot of different dimensions when you're talking about capacity management. So I'm going to touch on, like I said, I was going to touch on most of these and how these are actually determined and calculated, and where these all come into play. So the first thing we just kind of want to talk about, a lot of this stuff from a capacity management is based off our AI capacity engine. So we have a lot of predictive technologies that are available inside of Aria operations. So you can see here we're actually using this predictive technology in order to do capacity analytics, right sizing. I think those are the main ones we're going to be talking about today, because those are the ones that have the biggest impact for capacity. But the capacity engine also impacts other features as well, like workload placement or workload optimization, predictive DRS. There's other aspects that this engine actually applies to as well. So it's not just capacity. It actually helps found some of the other capabilities as well. So with that, like I said, I'm diving straight into the good stuff. So we're looking at the capacities. The first thing is to try to understand some of the terms that we talk about when we're looking at when you're looking at the UI within Aria operations. So I'm just going to kind of go through and explain some of the key concepts here, and then that should help you understand when I talk about these terms what they actually mean. So first off is total capacity. So that is like when you're looking, say, at a cluster, that's the total amount of capacity in the cluster. So that's the amount of capacity provided by all of the hosts within the cluster. Or if you're looking at a virtual machine, that's how much resources are allocated to a virtual machine. So, these terminologies do apply to basically any object that is capacity enabled: cluster, host, virtual machine, etc. So most of this is geared towards the cluster, because you see here we have HA. So from a cluster perspective, HA is the capacity that's reserved for failover on the cluster. So in a cluster, that is admission control. So you go and configure how many hosts you want to tolerate a failure of, or how much percentage of capacity you want to reserve for HA. You can go in and configure those admission control settings, however you want to configure them, and then that is what is accounted for here in HA. Buffer. So buffer is terminology or a feature that's within Aria operations. So this gives you the ability to reserve additional space above HA. So if you configure admission control, or if you don't configure admission control, you can go in here and configure a buffer. So there's some customers that don't enable admission control; they just allow everything to run. But then they go into Aria operations and say, I want to reserve, say, 25% of my capacity for failover purposes. So then this applies above and beyond admission control. So that it's really useful for customers that don't use admission control, but you can use it for, say, like a stretch cluster. You have a cluster that's going across two sites. You want to reserve 50% in case one site goes down. So different use cases like that. Okay, so when you take out your HA and buffer from your total capacity, that gives you what we call usable capacity after HA and buffer. And it's a very long name, but it's descriptive. Basically that's the amount of capacity you have left after you take out what you need for HA and buffer. So that's how much you can actually use in the cluster and still maintain your performance in the event of a failure or degraded capacity in your cluster. So that's really the important one when you're looking at from a capacity perspective, is that usable capacity after HA and buffers. Okay, so the next one is overhead. So this is basically, the resources that the hypervisor needs to run the virtual machines. So it can be a little bit of memory, a little bit of CPU. It's what the hypervisor needs to consume to be able to make those virtual machines run for you. So, it is a small piece, but it is something that does need to be accounted for. So the next one we have usage or utilization. Depending on the metric, we use a different terminology. So basically, this is the amount of physical resources that the workload is consuming. So this is how much is actually being used by that workload or by the virtual machine or the hosts. Demand. So demand is the amount of capacity that the workload is asking for. So that doesn't mean what the workload is getting. So you can have you can have the workload using a certain amount of resources, and then demand could be higher because there is what we call contention. So that is basically you could have CPU ready time or swap or things like that. Basically, you have overutilization of resources. There's contention where the virtual machine cannot get all the resources that it needs or it's wanting to be able to run the workload. So that's where what we call contention. So basically the difference between utilization and demand is contention. So hopefully that makes sense. Just kind of the key terminologies. So that's the first part. So now all of those different metrics that I just talked about, those are fed into the capacity engine. So the capacity engine does its analytics, and it does that every 5 minutes. So as there's a new update for the usable capacity or for the demand, it feeds that into the capacity engine and it generates new projections. So these projections are things like time remaining, capacity remainings, VM remainings, recommended size, etc. So it does this every 5 minutes. Every time there's a new data point that comes in, it'll do these projections up to a year up into the future. And then it tries to predict the usage of or the demand of that workload, and it tries to fit as much of the workload as it can. Mentioned here it covers 90% of the future data points. So that can be configured. I'll talk a little bit about how you can configure how much of the peaks and usage actually gets incorporated in those projections. And then there are some objects, such as virtual machines, where usable capacity and total capacity are the same thing. Because there is no HA when you're talking about a virtual machine, that's something that only applies to that cluster. So you'll see, basically the usable capacity is the total capacity for the virtual machine, and it uses that to determine all of these projections for the virtual machine. So hopefully that makes sense. Okay, so now we'll talk about there's basically two different ways of looking at your capacity in your environment. So the first one is looking at it from a demand model. So this is using the demand that I talked about just a moment ago. So this is actually looking at the actual utilization. It takes into account contention, and it basically drives for the maximum utilization of your cluster. It's driven based on performance. That's the key part when you're looking at demand. It's what's actually consuming, what it needs. And then on the other hand, we have what's called allocation. So this is where you actually are doing capacity planning based on things like overcommit ratios. Like I want to run 4 vCPUs per core, or maybe I have a supercritical environment and I don't want to overcommit at all. I just want to run 1 vCPU per core. I want to use 1 gigabyte of memory per physical gigabyte of memory. I can configure it to do that, where it's like I don't care about utilization. I just care about what I've allocated to the virtual machines versus what I can allocate on the physical environment. So allocation, basically, there is no utilization involved here. This is purely based on what is allocated to the virtual machine compared to the overcommit ratios that you have configured for the cluster itself. So the system does look at both. Demand is always enabled; it's always being calculated, and allocation is something that is optional. So you can optionally enable allocation model. So it always looks at, if you have allocation model enabled, it'll look at both allocation model and demand. Or if you don't have allocation model enabled, it only looks at demand. So hopefully that makes sense. So since we're talking about allocation model, like I was saying, the important part here is defining your overcommit ratios. So this is how many vCPUs per core you want to run, how many gigabytes of virtual machine memory to physical memory you want to run, and then how much virtual disk space you want to overcommit compared to the physical disk space that you have. So you can configure each of these. You can, if you want to just configure it for CPU and not memory, you can do that. You can configure CPU, memory, or disk space. You can actually pick one or two or three of them. It's really up to you. So the key part here is it uses these overcommit ratios compared to the number of, like say a CPU. Like you do a 4 vCPUs to core, and the cluster has, say, 10 cores, that means your total capacity will be 40 vCPUs. So I take my overcommit ratio times my the number of physical cores, and that gives me my total capacity in vCPUs. So that's the important part, is when you're talking allocation model, it's easy to understand in CPU because it's vCPUs where demand is in megahertz or gigahertz of CPU. So the units are very different. Okay, so now when you want to go in and start tweaking some of the settings within your capacity projections, there's a bunch of different settings. So I'm going to go through and talk about the different settings and how those settings impact those projections, so you can understand how to configure those best to fit your environment. So the first one here I'm going to talk about is what we call time remaining risk level. So you basically have two options here. You can either set it to conservative or you can set it to aggressive. So if you set it to conservative, it will look at the upper bound for that projection range. So I've got some infographics I'll show a little bit in more detail, but the projection that's into the future, has this range, has an upper bound, a lower bound, and conservative looks at the upper bound. So basically the worst case scenario based on that projection is what it uses. And then aggressive, it takes the upper bound and lower bound and calculates the mean or the average of those two numbers, and then it uses that mean in order to come up with those projections. So that's the key part there. Conservative is the upper bound and aggressive is the mean. Okay, so the next part here is how we kind of deal with some of the peaks. So we have this option here called peak focused mode. So if you have a workload that has a lot of like short little peaks that don't last for very long, you may see that some of those might get ignored. So if you feel that some of those peaks are getting ignored and they're important, you can go in and enable this peak focus mode, and that basically gives more weight to those peaks. So it basically concentrates more on the peaks when it's coming up with those projections, rather than looking at the entire workload. It looks at those peaks. So you see the difference on the infographics here, or the screenshots here. You can see with peak focus mode, it definitely is pushed much higher because of those peaks that are happening. So hopefully that makes sense. And that works both in conservative and aggressive mode. You can have it in, look at those peaks more. Okay, so the next thing here is what we call conservativeness level. So when you have conservative risk levels set, you have the ability to set these levels of 1 through 5, where 1 is the least conservative and 5 is the most conservative. So if you say, you've got this workload and it's even more sensitive, maybe you want to have these peaks have more an impact on the projection, you can bump the conservativeness level up to, say, level 4. The default is 3, by the way, but you can bump it up to level 4. I wouldn't go straight to level 5. I would do it gradually, set it to 4, see what it looks like, give it like 5 minutes, look at the change. If you like it, good. If not, bump it up to 5, look at the change. And the same thing if you want to lower it, you can go down to 2 or 1. So I would say, you want to go higher for more risk averse environments, like like your tier 1 production critical, business critical environments. Maybe you want to set the conservativeness level a little higher, and then like dev and test environments, you can set it lower, where you can take a little more risk in there. So hopefully that makes sense. That like I said, that only applies to when you're using the conservative mode. Okay, so then the next one here is business hours awareness. So what you do is when you have workloads that, say, only have utilization for, say, Monday through Friday, 8 to 5, you can actually go and tell the capacity engine to just look at these business hour timeframes and then kind of ignore the utilization or the demand that happens after business hours. So this can be useful for things like you have nightly backups running, you have patches running or AV scans, those kind of can be intense workloads that could potentially skew some of the projections. Maybe you want to exclude those. It gives you that kind of flexibility, so you can go in and set those business hour ranges and then have it take those into account. So this works both at the cluster level and at the virtual machine level. So if you do it at the VM level, it affects your right sizing recommendations. If you do it at the cluster level, that affects the capacity projections on the cluster itself. So I would encourage you to probably concentrate more on using this on the VM side to make it impact the virtual machines, and then leave the cluster level as is, not using the business hours. That way you can detect if if these maintenance tasks impact the cluster level capacity, but you can still ignore it at the VM level. So you do have that kind of flexibility. But you'll see down here on the bottom when you're looking in the UI, you'll notice the difference in the legend. You'll have the business hours colored as purple and non-business hours colored as gray. So it makes it easy to see that visually, what it looks like when you have that the business hours enabled. And then there's this little tooltip that you can look at so you can see what the business hours are configured for that particular workload. So, okay, so now I want to get in and talk about these metrics that are coming out of the capacity engine and how these are determined. So like I said, some of these change depending on whether you have conservative or aggressive enabled. So I have basically versions of each of these that I'll kind of talk through. So what I have here now is showing the time remaining. So this is when you have it set to conservative. So time remaining is looking at the projection. Here we see here's my projection range. So they have the upper bound here because I'm conservative. And looking at where this upper bound of my projection hits the usable capacity line. And whatever day that's projected to be, that tells me my time remaining. So between now and that point when the upper bound crosses the usable capacity line, that tells me how much time remaining I have. So hopefully that makes sense. And then if we switch over to aggressive, you can see now the mean. So this is the mean of the upper and lower bound. And we're looking at where that mean touches the usable capacity line. So at that point, between that point and now, that tells me what my time remaining is. So the number of days there. So hopefully that's clear. So capacity remaining. So this one can be somewhat confusing. So it's important to understand that capacity remaining is based on a projection 3 days in the future. So it uses that projection, goes out 3 days, and then it looks at the difference between the upper bound and the usable capacity line. That tells me how much capacity I have remaining when I'm using conservative mode. Now this is different than say you look at the projection, the capacity remaining projection for your data store versus looking at the free space on my data store, because free space is looking at right now and capacity remaining is looking at that projection 3 days in the future. So when you're looking at that in the UI, it can be confusing if you don't realize that capacity remaining is based on that projection. So I think that's the important part to understand here, is that it is projected 3 days out in the future. And that's done to help kind of smooth out some of that variability. So you can have workloads going up and down, and it kind of smooths that out a little bit by doing that projection just 3 days out in the future. So it's close enough that it's still pretty current, but it's far enough out that you can get rid of some of that fluctuations that you can see with free space. So aggressive now looks at the mean between the upper and lower bound projections, and it projects that out 3 days, and the difference between that and my usable capacity line gives me my capacity remaining. So just like with conservative, that is based on that 3 days in the future, but it's based on the mean now instead of the upper bound. So hopefully that makes sense. Okay. So the next piece here is I'm going to talk a little bit about what we call the time remaining score threshold. So the time remaining score threshold is where you can tell the system basically when to start alerting you or telling you when you're running out of capacity. So by default, a cluster will turn yellow if there's 120 days worth of time remaining, or it turns red at 90 days. For virtual machines, the default is 30 days for warning and 10 days for critical. So, this is, like I said, this is to give you that proactive warning. So it gives you, at the cluster level, gives you time to go and purchase new hosts, get them online, configured, ready to go. And the virtual machine level, that gives you time to go and right-size the virtual machine before it runs out of capacity. So that's basically what those are intended to do. But like I said, these do impact those right-sizing recommendations and your total capacity recommendations for the cluster itself. So how does that work? Let me show you that now. So when we're calculating recommended size is what's used for right-sizing recommendations for virtual machines. So you can see here, I have my upper bound. I take my upper bound projection, and then I go out. You see where it hits the usable capacity line, and then I go out 30 more days, and that gives me my projected utilization. So I take my time remaining score threshold, which by default is 30 days. I add 30 days to that, and now I can say, okay, within 60 days, this is what I project my workload to be. So that's what I will use to determine the recommended size of my virtual machine. So hopefully that makes sense. It's looking at the upper bound projection, take your time remaining score, adds 30 days to get that window of how far out in the future it looks. And it says, okay, it's using this much CPU or this much memory. And it says that's how much I need to add or remove from my virtual machine based on that projection. So hopefully that's clear. It's the really important part is that time remaining score threshold that you configure in the policy. Aggressive now is this the same, but we're looking at the mean. So we go out the time remaining score threshold configuration time plus 30 days, which is 60 days by default for virtual machines, and that gives me what my recommended size would be running in aggressive mode. So out here. So okay. It's important to know that with the recommended size, it's not just looking at the end of that projection range. So like for virtual machines, it's not just saying this is what it will be 60 days in the future. So that's what my recommended size will be. It's actually looking at the peak within that range. So the peak could be at the beginning of that window. It could be in the middle. It could be at the end. It really depends on how the workload is going and how it changes throughout that projection window. So just understand that it's actually the peak within that planning window. So it could be anywhere within that window that could happen. Okay, so now switch over and talk about at the cluster level. So this is still looking at the recommended size, but this is the recommended total capacity. So the difference here is basically it uses the recommended size. You can see where we just talked about, but now it adds on what's needed for HA and buffer. So it adds in the admission control and buffer settings, and that gets me my recommended total capacity. So this is what you will see on things like at the cluster level. So it looks at it projects the utilization of the cluster out, and then it adds in HA and buffer, and it says, okay, now this cluster needs to have this much capacity to run the workload within my planning window. And remember, by default, it's 90 days plus the 30 days. So it gives me 120 days by default. It looks out 120 days that says, this is what capacity I should have for my cluster to handle the projected workload out in that window, within that window. So hopefully that makes sense. And aggressive, it's the same thing, but now it's looking at the mean, and then it adds in HA and buffer, gives me my total capacity based on the mean of my projection range. Okay, so this is basically a consolidated chart. This is where I put basically all of the key terms in here. So if you want to grab a screenshot of that, this basically shows you, where all the various components come within the projection and how they get impacted by the projection of the workload. So this is the conservative version, and then switch over here. Now this is the aggressive version. So this, like I said, this covers all the key terminologies that I just kind of talked through. So it should help you understand, what all these different metrics are when you're looking at the capacity. Okay. A couple other things to talk about here. There is, when we're looking at oversized and undersized virtual machines, there is basically an artificial cap on the recommended size. And this is done to basically keep the recommendations a little more conservative. So when you have an oversized virtual machine, it basically will not recommend removing more than 50% of the utilization of that, of the allocation of that virtual machine at a time. So the example here, if I have a virtual machine running 8 vCPUs, but it's never used more than 10% of the CPU, instead of it saying, yank out 7 of the CPUs, it's going to say go to 4 CPUs. Once you do that take out those 4 CPUs, then the next, it'll monitor it for a little bit and then give you another recommendation. So you kind of slowly stair step down to the recommended size instead of doing something so substantial as taking away 90% of the allocated resources. This kind of tries to make it a bit more conservative. So the other way around, looking at undersized recommendations, it caps it at 100%. So the example, if you have a VM with 4 vCPUs, you won't see a recommendation going any higher than 8 vCPUs in a single step. So basically it'll tell you to add how many vCPUs to add, and then you go and do that, make the change, and then give it a little bit to see how it's going, and then it'll come up with a new recommendation whether to add more CPUs or remove more CPU. So the idea is you can slowly kind of get your way into the right size, and you can automate all this using Automation Central. You can have it say right size the virtual machine every weekend. You just have it go and apply the recommended size to the virtual machine, so it can be make it larger, smaller. So you can go and automate the entire process if you wanted to. Okay, so another question that we get a lot is the projection. What goes into the projection? How much historical data is actually used by this projection? So basically, the short answer is all of the historical data it has an impact on the projection. If you want to see that, you can go in the UI and you can look for this line over here, this projection calculation start point. And you'll see, when you see that vertical line, that basically tells you where the projections start. So like I said, by default, it basically it uses all of the historical data. And even if you go and set your global setting to reduce your data retention, say you only keep 30 days worth of data, even the data prior to that 30 days has an impact on the capacity calculations. So even if you purge the data, it still has an impact on it. So it actually has an impact on the projection, and it continues to have that impact as the virtual machine exists. Now we also have this thing called exponential decay. So exponential decay will basically give higher weight to utilization that's more recent. So workload never stays the same. So say something that happened last week is more important than something that happened last month. So you want to have ensure that you account you count more for the more recent changes than the older changes. That doesn't mean it's going to ignore periodic patterns that happen. This just basically says, it's more important what's happened more recently, and it kind of gives that weight when it comes up with those projections. So like I was saying, with the projection calculation start point, that is the default. But if you go and in the system, you can actually reset the start point. So you can go and say, I want to reset it back on, say last Monday. Maybe we made some major changes in the environment. Maybe I deleted a whole bunch of virtual machines, or I retired a data store, or I made some kind of significant change in the environment, and those changes aren't happening fast enough for me. So I can go in and say, let's just reset the calculation, the day after that big change happened or that big event. So the idea there is, if you want to ignore, older usage, you can. You just go in there and say reset the capacity calculation start point, and then you'll notice that change, that line, show up in the chart. You'll see that new projection calculation start point, and you can go back and you can even go and change it again. After you do it, you can go back and change it to something that was further in the past if you wanted to, or you can change it, something closer to now. So there's a lot of flexibility into that. So hopefully that helps make sense. And then I know the other thing that comes up quite a bit is peaks. How are peaks handled? What do the peaks do? Are there different kind of peaks? Things like that. So I've got this very simplistic diagram here that kind of showing the different types of peaks that we consider. So there are the first one is momentary peaks. So these are short-lived peaks. These maybe there was a reboot. Maybe it was something just something that just kind of like a little blip that happened. When you look at the projection, you say, oh, that just happened once. It hasn't happened again. It's not important. So, you would just ignore it. If it's something like that, it's just, it doesn't look like it's big enough to even worry about. So you'll see those kind of peaks that happen. There are some kind of peaks that when you look at the projection, you see the system just ignored it. And that's because it thinks it's just a momentary peak. In the grand scheme of things, it's not enough to influence the projection. So it'll ignore some of those. And that's where you can change the things like the conservativeness level and the peak focus mode to help it influence and take into account some more of these momentary peaks. So that was the settings that I talked about earlier. Sustained peaks. So these are peaks that last for a longer time. So these are ones that, you start to say, that looks suspicious. Maybe that's something that's going to happen again because it lasted for so long. That's when when you look at it, you think, yeah, I can't ignore it. It may not be anything, but let's just make that part of our projection. So when you see those kind of peaks, you'll see your projection range increase. So it becomes much larger because there's now more uncertainty whether that peak is going to come back. So that's why we call it these sustained peaks. That's where, as I say, the projection range grows when it thinks that peak might be important. It doesn't know for sure because you see the projection over here wasn't impacted, but the range increased and it got larger. And then the last one to talk about here is the periodic peaks. So this is where the system goes and does these this analysis on the different waveforms in the demand pattern, and it looks for those periodic patterns. So it looks for things like hourly, daily, weekly, monthly, etc., and even looks for like days of the month, days of the week, things like that. So it looks for these periodic patterns. And then once it detects those patterns, you will see those patterns show up in the projection over here. So you see this kind of sawtooth pattern that showed up over here on the right. So that's when you notice that it started to detect the periodicity in some of these peaks, and then it actually includes those in that projection. So hopefully that makes sense. It looks at these different kind of peaks and it kind of handles each of them different ways. And like I talked about earlier, you really want to set your conservativeness level to have more influence on which of these peaks are, how much of these peaks are considered. You raise it up if you want more peaks to be included, or lower it down if you want to reduce the impact of those peaks. Okay. So now I'm going to talk a little bit about some of the terminology that we have in the UI. So it makes some sense when you're looking at these numbers. So all of the capacity enable objects have a capacity tab. So when you go to that capacity tab, it defaults to the time remaining. So it shows you the time remaining there. So remember when I talked about how time remaining is calculated, it calculates that time remaining on CPU, memory, and disk space. And then if you have allocation enabled, it'll also look at CPU allocation, memory allocation, and disk space allocation. So you could have 6 different dimensions that is doing these projections for every 5 minutes. And then it looks at the most constrained of each of those capacity models that are enabled. And it says, okay, my most constrained here is 48 days for time remaining based on memory allocation. So because that's the most constrained, that's what it says the time remaining is for that particular object. It could be cluster, virtual machine, whichever object I'm on. So hopefully that makes sense. This is showing me the most constrained time remaining of all of the different capacity models. Hopefully that's clear. Okay, now when you click over on the right side here on capacity remaining, you'll see over here, we'll see this virtual machines remaining. The virtual machines remaining is where the system will take And by default, it just looks at the average virtual machine. So it looks at the average demand of the virtual machine or the average allocation of the virtual machine if you have allocation model enabled. And then it tries to determine how many more virtual machines you can fit within that cluster. So it says, I have this much CPU and memory capacity remaining. My average virtual machine is this size. Oh, therefore, I can fit, say, 10 more virtual machines within my cluster. So hopefully that makes sense. It's trying to give you that capacity in a terminology that's a little easier to understand because it basically tells you how many VMs you can fit. You also have the ability to create what we call VM profiles. So you can see here in this screenshot, we've got large, medium, small VMs. So I've gone in and created these profiles that says this is what a large VM means in my environment. So I can say, a large is 4 CPUs, 32 gigabytes of memory. I can go in and define that in the system. It says, this is what a small, medium, large means for me. And then it'll give me those projections for each of those different virtual machines profiles. Like I said, by default, it does average, and then you can add these profiles in to get it to calculate those additional ones for you. Oh, and one other thing. Down here on the bottom, this is the part that can be confusing because you notice here where it says used and recommended size and remaining. Just remember, like I was talking about, these are all based on that projection 3 days in the future. So when you see used, remaining, and recommended size, those are all based on those projections. So don't do a comparison based on like the free space, disk free space, and then expect it to be the same as remaining here because remaining is based on that projection. So really, really important because it can be confusing. And there's a little tooltip on that page. It's not in this screenshot here, but there's a little tooltip, little info icon that you can click on that explains that if you have a question. Okay, so the next one here is virtual machines remaining. If you have too many virtual machines provisioned in a cluster, you'll see it shows capacity remaining of 0, and then it switches from virtual machines remaining to shortfall. So it tells you how many virtual machines you have provisioned beyond the usable capacity of your cluster. So this is where you should go in and remove some virtual machines off to another cluster, retire some unused virtual machines, do something to reduce the utilization of the cluster itself. So it kind of gives you that target of how many VMs you should go and either clean up or move. And then the custom profiles, this showing here how you can go and create these. You can see the examples up here, large, medium, and small, and you can go and define what the CPU and memory usage would be for each of those. It's important to know that if you only have demand model enabled, it only looks at the demand numbers here. So this would be the CPU usage on host and disk space usage on data store. If you have allocation model enabled, you can enter the allocation numbers here and it'll take those into account. So CPU allocation, memory allocation, and disk space allocation. So it's important, you don't want to create a profile that only has allocation numbers in it and apply it to a cluster that only has demand model enabled. You won't actually get any projections for VMs remaining if you do that. So you just remember that what you enable in the profile has to match what's enabled on the cluster itself. So hopefully that's clear. So that's all the slides that I had to go through. It looks like I've got a few questions in the Q&A section. So let me run through those real quick. And if anybody has any other questions, feel free to post in the question panel and I will try to answer them for you. So the first question here, are you gathering all the peaks from vCenter metrics or just capture every 5 minutes and disregard the peaks in between? So Aria Operations does its data collection every 5 minutes by default, and it will average out the utilization within that 5-minute window. So it's basically based on the average within that 5-minute range. Now, a couple options: you can reduce the collection cycle time, but that has a pretty big impact. Basically it's significant increase in the amount of storage that you have to store, and it can increase the load on vCenter a little bit by doing collection every 1 minute instead of every 5 minutes. So there are some stuff you can do there, and we also have some metrics in the system called peak within collection cycle. You can use those metrics to see what the peak was within that 5-minute window to see if there were any any peaks in there that you need to be concerned about. So hopefully that answers your question there. The next one here is, are the business hour ranges also available for CPU and memory reports? So what I showed there, the business hours, is what impacts the capacity projections. So you can use that to influence what goes into those projections. But for reports, you can actually go in views and define business hours within a view. So when you create a report, you can have it show, say, the average or the peak or whatever within that business hour range that you define. So that is done within the view configuration, and you can have multiple views in a report or on a dashboard. So that's the way you would do it for a report. You just configure it in the view itself. And then the last question I have here is, how do you assess memory oversize based on active memory, based on consumed memory? Are you tracing swapping metrics on the VM or OS? So yeah, so that's a really great question. So from a virtual machines perspective, we use VM tools to gather the memory utilization from inside the guest OS. So we actually look at basically, it's similar to what you would see in Task Manager. So if you look on the virtual machine, the metric is called memory utilization KB, and that is based on the metric coming from from VMware tools called guest, and then it's memory needed. I have a blog post that I wrote. Let me share real quick. So I go really in depth into the right sizing and how that works. So I would encourage you to read that if you want to learn, even more about right sizing. There's even more stuff that I went through on the call today. But basically, talk about how these memory metrics are consumed. On the memory ones, I have enhancements. I can post these in the chat here in just a moment. And then here's another blog. This one talks about the memory metrics for virtual machines, difference between active, consumed, and then the guest needed memory metrics that we collect from VMware tools. So basically what that means is when you're looking at the right sizing recommendations at the VM level, it's based on the memory utilization as seen from inside the guest OS. So it doesn't use consumed memory, it doesn't use active memory. It actually uses what the guest OS understands is needed for the virtual machines. And then the other question is swap accounted for? Yes, swap is accounted for in the right sizing recommendations for the guest virtual machines. So like I said, you can read these two blog posts, and it goes really in depth on the memory metrics and how we account for those, account for the memory and the virtual machine. So there's any more questions, I'd happy to answer. Let's see, how do I post these in the chat? All right, I think I can do it here. Did that work? All right. All right, hopefully that is showing now.
Good.
Okay, if there's any more questions, happy to answer. I don't see any at the moment. I do see a request for the slides. Sure, yeah, we can. I can figure out how to publish these slides, so you can have these available as well. So
one of the things we could do is if you want to publish the slides, we can put them up as a file on the blog. So on blogs.vmware.com, where we have the record of all of these sessions, I can put that up on that page, or we can also ostensibly put that up on the Tech Zone page as well.
That's a good idea. Yeah, I can post it on Tech Zone, and then maybe we can publish it on the blogs, link to the Tech Zone page in the blogs. That should work. Okay, yeah, I'll do that. Awesome. I don't see any more questions. I appreciate everybody for joining today. Hopefully it was useful for you. Hopefully you have a better understanding of how all this capacity metrics are done in Aria operations.
Awesome. All righty. Thank you, sir. And thanks, folks, for joining. And we will catch up with you all next week. Next week is going to be run through the StreamYard platform, available on all the social channels. So be sure to check out the Aria social channels. The advertisements are there, and there's also direct links available in the blog on the management blog platform. And we'll have the recording on this up hopefully by the end of the week for you to share out to anybody who may have missed it. And we appreciate your coming back and checking us out. Talk to y'all soon.
Awesome. Have a great day.